Hello everyone, my name is Victor, your organic chemistry tutor, and in this video we're going to draw Newman projections for all these molecules. So without any further ado, grab yourself a cup of coffee, a notebook to work through these examples with me, hit the like button for good luck on the test, and let's get started. So the first molecule that I have over here, I'm going to imagine myself standing in front of this molecule just like that. So I'm standing right over here and looking at this from this direction. Now, it's always easier for me to imagine myself in front of the molecule rather than just have the imaginary eye or something like that, because this way I can kind of use my body to orient myself around the molecule and orient the molecule around me as well. So what I'm seeing on the front atom is going to be the propyl group, the 3-carbon chain looking directly down. Then to my right up, I have the chlorine atom, and to my left, I have the hydrogen atom like that. Now, on the back atom, I only see the OH group right now. So I also know that I have a couple of implicit hydrogens there, so I'm going to show them as well. One hydrogen would have to be on the wedge, while the other hydrogen would have to be on the dash like that. So in this case, the OH on the back atom is looking directly down again, and the one hydrogen is going to be to the right and another hydrogen is going to be to the left like that. So that, what I have in front of me here, is going to be an eclipsed conformation. So remember how I was talking in my Newman projections video? I imagine that this line between the front and the back atom is my horizon, so anything below the horizon, which is going to be right over here, is going to be looking down. Anything on the wedges that I have over here, if I'm looking from left to right, is going to be on the right side, so those are my wedges, and anything on the left side, those are going to be on the dashes. So these are my dashes, and if I'm looking at my molecule from left to right, those dashes are looking away from us from the paper perspective, so to speak. And of course, anything that we have in the plane of paper is going to be on the vertical line, so that is my plane of paper like that. So the OH and the propyl group are on plane lines, which means that they gotta be in the plane of paper. Alright, let's clean it all up because it's kind of messy with all those helpers. And since this is the eclipsed conformation, it's rather unstable, so let's convert that into a more stable staggered conformation. So in order to do that, I will have, let's say, my front atom stationary, so I will redraw my front atom just as is. So I have my chlorine here, hydrogen there, propyl group looking down, and on my back atom, what I'm going to do with that one, I'm going to rotate it counterclockwise like this. So I'm going to have now the OH group looking up, and then I have a couple of hydrogens just like that. Easy enough, right? Alright, let's look at the next example. So for the next example, I'm again going to imagine myself standing in front of the molecule right over here, and on the front atom I am missing a group because I only see a couple of groups on the front atom, so that means that I gotta have the implicit hydrogen looking away from me. Then on the back atom, I again going to have one implicit hydrogen on the wedge and another implicit hydrogen on the dash like that. So now on our front atom, we have the CH3 group looking down at the bottom again, it looks towards my feet. Then on my right, I have a hydrogen. On my left, I have an OH group. And notice that since in this case, I'm looking at the molecule from the opposite direction, not from left to right like in the first example, but now from right to left. So now all the wedges are going to be on the left side of the molecule, and all the dashes are going to be on the right side of the molecule. So on the back, what I have there, I have another CH3 group, so I will squeeze it right there, and then I have a couple of hydrogens. I have one hydrogen and another hydrogen. So this one is again an eclipsed conformation. We don't like that much, so we are going to rotate that around, and again I'm going to keep my front atom just as is, so I will redraw it CH3 here. I've got my hydrogen on the right, OH on the left. Now in the back, I'm going to do the same thing as in the last case. I'm going to rotate my back atom by 180 degrees, so I'm going to end up with CH3 looking up, and I have a couple of hydrogens looking to the sides, just like that. Alright, example number 3. I am standing in front of the molecule like this and looking at that from right to left again. But now I have a cyclic molecule, which actually is not that bad. The idea is exactly the same as before. So I'm going to look at my front atom. So the front atom has a CH2 looking up, which is this CH2 over here. Actually, let me highlight it. I'm going to highlight it in green like that. So it's that CH2 group. Then on my right side, I have the chlorine atom. On the left side, I have the implicit hydrogen. I will show it on my molecule as well, over here like that. Then on the back, I have another CH2 that's going to be looking directly up. I will highlight it in orange like that. So that CH2 is, let's say it's hiding right there behind my green CH2. So that one is my orange CH2 over here. Then I have the CH3 group on the left side, so I will draw that one here like that, and I have another implicit hydrogen down there, so I will show that implicit hydrogen right behind my chlorine. Now, I also have one other atom that I do need to show in my molecule, and that is going to be this pink CH2. So in order to show that one, well, that gotta be connected to both green and orange CH2s, so I'm just going to draw CH2 here like that and connect them to the rest of my molecule. And in this case, I cannot do a full 180 degree rotation, but I can do about 60 degree rotation. So I'll keep my front atom just as is, and in this case, I will end up with the CH2 looking still up. Then I have chlorine to the right, hydrogen to the left. I will rotate my back atom by 60 degrees counterclockwise like this. So that means that my orange CH2 is going to be right over here, my hydrogen is going to be there, and my CH3 group is down here. So now I only need to add my pink CH, which would be right there, and connect them just like that. So in this case, my green CH2 is here, my orange CH2 is right there, and my pink CH2 is right over here. So don't be afraid of the cyclic compounds. Drawing the Newman projection for the cyclic compound is literally the same thing as drawing a Newman projection for anything else. The rules are still exactly the same, the approach is the same. The only thing that you gotta remember is that a couple of groups, one group on the front atom, one group on the back atom, they will have to be interconnected somehow. So it might be by one CH2 group, it can be by something a little bit more complicated, but just draw whatever that chain you have that connects them, and that's it. Alright, the next molecule, well, that one is kind of interesting because now we actually are looking at our molecule from up above. Well, I'm going to imagine myself standing in front of it like that. So here are my glasses, I'm a bald guy, so here's my very thin hair on top of my head, so I'm going to be looking at this molecule like this. So from this perspective, what I'm seeing on my right, I'm going to have that group with the double bond. On my left, looking a little bit up, I'm going to have a CH3 group. And then on the bottom left, I'm going to have a hydrogen. That one is an implicit hydrogen that's hiding behind my CH3 like that. Then on my back atom, so on the back atom, I have a CH3. I will try to squeeze it down there. I don't know how much you can see, but it is there. Then we have the OH. It is also going to be eclipsed, so OH is behind my hydrogen. And we also have an implicit hydrogen on the back atom, which is going to be right over here. And that implicit hydrogen is going to be hiding behind my CH3 group. Looks like I'm doing a lot of eclipse conformations today. So, to make this one look a little bit better, we are going to keep the front atom as is. So I'm going to draw this one here. Then I have my CH3. Then I have my hydrogen. Then on the back, I will just rotate it a little bit. So I have a staggered conformation with CH3 over here. Then hydrogen there. And also I have my OH group just like that. Yeah, it's not the very common way of drawing Newman projections like that. Normally we would want to draw our Newman projection as a peace sign or the Y shape, but that's a perfectly legit way of drawing Newman projection as well, and if you want to draw it like that, well, there are no rules that say you cannot. Alright, so the next one, I am standing in front of my molecule just like that. Then I remember that since I need to have 3 different groups on each atom, I have the implicit hydrogen over here. Since I already have a plain line and a wedged line, the hydrogen must be looking away from us, must be on the dash, so I'm going to add it on the dash like that. Then what I'm seeing on my front atom, so to my right is going to be the hydrogen, to my left is going to be the CH3 group, and then on the bottom I have a chain of 3 carbons like that. Then on my back atom, over here, I have CH2 phenyl group like that. And one very common mistake that I see a lot of students make, they forget about this CH2 group over here. Don't forget about that thing. Don't just skip it. Don't show that the pH is directly connected to your back atom. Well, it is not. So make sure that you account for all of the atoms in your molecule. Don't just skip them or forget about them or assume they're somewhere there. You gotta show everything. Alright, so then on my back atom to my right I have the CH3 group, and to my left bottom I have OH just like that. And since this is already a staggered conformation, I don't need to rotate anything around, and if I wanted to figure out whether it's the most stable or the least stable staggered conformation, I would look at my bulkiest groups, and I see that this CH2PH is a very bulky group, and on the front atom my bulkiest group is going to be this propyl chain, and they're already looking opposite from each other, they're already anti to each other, so that is already going to be my most stable conformation, so I wouldn't even need to do anything to that, unless of course I needed to draw the least stable conformation or something like that, so then I would rotate them to make them eclipsed. In the next one we have a cyclic molecule again, and as we already know, the rules are still the same. We are going to imagine ourselves standing in front of the molecule just like that, and on the front atom I'm going to see the chlorine, the CH2, which is the part of the ring, and also I have the implicit hydrogen, which I will show over here like that. Then on the back atom, so here is going to be my back atom, I have chlorine on the left, so I will show it there. I have an implicit hydrogen, which gotta be on the wedge, just like that, so I will show that implicit hydrogen behind my chlorine, and I have another CH2. So my green CH2, this one is on the front atom, my orange CH2 is this one on the back atom, and I also have a pink group, well, it's actually 2 carbons there, so I need to add 2 carbons over here to complete my chain, so I can do just like that. And that completes my structure over here. If I wanted to make it a little bit more stable, if I didn't want to keep it in the eclipsed form like that, I would rotate either front or the back atom by 60 degrees. So if I keep my front atom just as is, I will redraw it. I have hydrogen here, I've got my chlorine, I've got my CH2, and then I have my back atom. Let's say we will rotate it by 60 degrees clockwise, so we are going to be going in this direction like that. So my chlorine is going to be here, my hydrogen is going to be there, and I also have my CH2 group, and both of my CH2s need to be connected to each other like that by a small chain of 2 carbons. Alright, the first example here is the dreaded double Newman projection. For something like that, that generally indicates that we are going to draw a Newman projection of a chair conformation. And I don't know why a lot of people hate it, I think it's kind of fun. So first thing first, let's start by drawing a chair conformation. So I'm going going to arbitrarily number my atom 1, 2, 3, 4, 5, and 6 like that, just so I have the anchor points, just so I, know where my atoms are. Next, I'm going to draw my chair. So I will go 3 by 1, 3 by 1. Then on the bottom, I'm going to go 3 by 1, 3 by 1. Connect those guys, and voila, I have a perfect chair. So my carbon number 1 is going to be here. I did the numbering clockwise before, so I'm going to do the numbering clockwise in my chair as well. So I'm going to have 1, 2, 3, 4, 5, and 6 like that. So on carbon number 1, my groups should look like this, and chlorine is on the wedge, which means that the chlorine atom is going to be in the up position, so I'm going to add my chlorine here. Then we do have an implicit hydrogen, so that implicit hydrogen is going to be in the down position. Then on carbon number 2, my groups should look like this. We have an implicit hydrogen that's going to be on the wedge, so the hydrogen is in the up position, while the OH group is in the down position. Then on carbon number 4, the correct positioning of groups is like this. So we have the isopropyl group on the wedge, so that is an up position, and implicit hydrogen is going to be the down position. And finally, on my last carbon, carbon number 5, my groups are going to be like this. Here I have CH3 in the up position, and we have bromine in the down position like that. So we are looking at the bonds between atoms 1 and 2 and 4 and 5 like this from the direction where the front atoms are. Well, look at that, right here, they are in the front. So making a Newman projection out of chair is actually very easy. I'm going to first look at my front atoms. My front atoms in both cases are right over here. So here is my one front atom, and here is my second front atom. So what I'm going to do, I will draw these two guys. So I have my isopropyl coming to front atom, which is connected to CH2, which is then connected to another front atom. We have hydrogen over here, OH looking down, and another hydrogen looking down like that. Now I'm going to look at my back atoms. So I have a back atom here, and I have another back atom over there. So I'm going to draw those ones. So on the back, I have CH3 looking up, bromine to the side, then we have CH2 in the middle, connecting to the other back atom, where I have chlorine looking up, hydrogen looking to the side. And there you get it. You have the Newman projection for a chair conformation for a 6-membered ring with a bunch of groups on it. So whenever you're facing a problem like that, my suggestion is going to be always draw your chair first, and then from chair it's going to be much easier to convert that chair into the Newman projection because you're literally just drawing what you're seeing there. And of course that only works when you draw a proper chair. If you are not very comfortable or familiar with how to draw a chair conformation, well, you should probably practice that, because as you can see, if you have drawn a proper chair, then converting them into a Newman projection is an easy job. But if your chair is all crooked with wrong angles and stuff like that, then there is no way you're going to be easily doing any analysis of that chair conformation whatsoever. Alright, next example, we are standing in front of my molecule like this. So on my front atom, we have a CH3 looking directly down. Then we have CH3 to our left, and we have an implicit hydrogen to our right. I will show that implicit hydrogen on the dash, and whenever we're looking at the molecule from right to left, the dashes are going to be on the right side of the Newman projection. Then on our back atom, we have the ethyl group looking up, so I will show it like this. We've got the OH group on the right bottom side, and we have another implicit hydrogen, which in this case would be on the wedge like that, on the bottom left. So from right to left, our wedges are on the left, dashes are on the right, and if we have it the other way around, then, well, it is the other way around. In this case, the confirmation is already staggered, so I don't really need to move anything around, so I am happy with this structure. And the last one is, again, a fun one where looking at our molecule from below up. So again, I'm going to imagine myself standing in front of this molecule like this, and looking at that from this direction. So what I'm seeing on the front atom is going to be the phenyl group on my direct right. Then chlorine is looking to the left up. The CH3 group is looking down left like that. Then on the back atom, I have the CH3 group in the same plane with the phenyl group, but on the left side. Now the OH is going to be on my top right, and we also have an implicit hydrogen over there. I'm going to draw it like that. So that implicit hydrogen is going to be on the bottom right. And of course, if I am very picky about how I draw my Newman projections, I can redraw it in a more classic way where it looks like a peace sign or a Y shape. So in this case, let's say we are going to draw it so that the phenyl group is up, which means that the chlorine is going to be to the left, CH3 is going to be to the right. Then on my back atom, I will show my OH here. The hydrogen is going to be on the right side, and the other CH3 on the back atom is going to be looking down. So what do you guys think about this kind of walkthrough videos whenever I'm just talking through the examples and I'm solving them as I go? If you like videos like that, let me know in the comments below. Click the like button, share this video with your friends and classmates, and I will see you tomorrow.